Okay, so this short video is on energy stores. Okay, so what I want you to do firstly is I want you to have a look at this and I want you to try and unscramble these 5 words into the 5 stores of energy. You might not know this, but some people might know this already. Okay, so I want you to pause the video and have a go at that. Okay, so the first energy store is thermal energy. Okay, the next one is elastic. Okay, think of like elastic bands. Okay, thermal is like heat or cold energy. Okay, temperature. Gravitational. Okay, this is things that are above the ground. Chemical. Okay, these things, chemical reactions. Kinetic, things that are moving. Okay, so next part, you've got the energy stores here. I want you to match these energy stores up with these definitions. Okay, so I want you to match these up to these definitions. Okay, so pause the video and have a go at that. Okay, so the thermal energy store, okay, is the energy stored due to temperature. Okay, it can either be heat, hot or cold. Okay, elastic, okay, the energy stored in a stretched object. Like I said, think about elastic bands. Okay, gravitational is the energy stored in an object above the ground. Chemical, okay, is the energy stored that is released in a chemical reaction. Okay, kinetic is the energy stored in a moving object. Okay, so we're going to go through some examples now. So what you can do is every time I change the slide, you can pause it, okay, and have a go and see if you can guess the energy store. Okay, so each object has got an energy store associated with it. Okay, so this is the radiator. Okay, so the radiator's energy store is going to be thermal. Okay, these are batteries. Okay, their energy store is going to be chemical. Okay, because there's stored energy inside, okay, which is released through chemical reactions. Okay, this is a spring. Okay, when it's pulled, it has elastic energy. This is Usain Bolt. Okay, he's moving. His energy store is going to be kinetic. Okay, now the plane. Okay, this has got 2 energy stores. Okay, because it's up in the air and it's also moving. So this would be gravitational and kinetic. Okay, so look at these images. Okay, what have these images got in common? Okay, and then what I want you to do once you've thought about that, okay, I want you to explain what will happen to these objects over time. Okay, so pause the video and have a go at that. Okay, so these 3 objects, okay, they're all thermal energy stores, okay, and they all produce light waves. Okay, so we've got metal, hot metal here, okay, we've got the stove, and we've got the sun. Okay, they're all hot, they all store thermal energy, okay, and they all release it as light waves. That's why we can see it. Okay, the master question, okay, explain what will happen to these objects over time. Over time, the amount of thermal energy stored will decrease. This will decrease the temperature of the object, meaning the colour and intensity of the light given out will change too. So basically, this hot piece of metal, okay, the thermal energy that is stored within will be transferred to the environment. Okay, so this means this will decrease, okay, and the temperature of the air will increase, okay, because the energy from here is being transferred to the air. Okay, so what I want you to do, using these keywords here, okay, so store, created, transferred, destroyed, another, okay, I want you to write out a sentence that is for the law of the conservation of energy. Okay, so pause the video now and do that, please. Okay, so the conservation of energy. Okay, energy cannot be created or destroyed. It can only be transferred from one store to another. Okay, so for example, like the hot metal earlier. Okay, that thermal energy, it's not being lost, it's not being destroyed. Okay, it's not being created or or anything like that. It's just being changed or transferred, okay? It's being transferred from one store to another. It's never destroyed, never created. Okay, so we've got an example here. So the radiator. As the radiator cools, its thermal energy store will decrease. Where is this heat going? What is happening to it? Okay, have a think about that, and then I want to have a think about the master question. So explain how the radiator in the classroom stays at the same temperature. Okay, so pause this and have a go, write your answers down. Okay, so the first part, okay, the surroundings around the radiator will start to heat up. So the thermal energy store in the radiator is being transferred to the thermal energy store of the surroundings. This means that as the hot water is going into the radiator, okay, the thermal energy is being transferred from the store in the water to the store in the metal. Okay, so the thermal energy store in the metal. From the metal of the radiator, it's going to go to the air. Okay, so basically, the thermal energy from the metal in the radiator, okay, is going to transfer to the thermal energy store of the surrounding air. Okay, so the mastered part of the question, it says if an object loses as much thermal energy as it gains, its temperature will remain constant. Okay, by supplying heat at the same rate that the heat is lost, then the temperature will remain constant. So what that means is, because radiators are heated with hot water, if the heat from the hot water is being transferred from the hot water's thermal energy store to the metal of the radiator's thermal energy store faster than it is being lost to the air, okay, to the air's thermal energy store, not lost, sorry, transferred, I should say. Okay, that means the radiator will increase in temperature. Okay, if it's the opposite way around and the thermal energy is being transferred to the air from the metal to the air faster than from the water to the metal, okay, it's going to be losing temperature. Okay, if it transfers at the same rate, so if the thermal energy from the water's energy store transfers from the water to the metal's thermal energy store at the same rate as it transfers from the metal's thermal energy store to the air's thermal energy store, then the radiator is going to remain at a constant temperature. Okay, so all energy stores will eventually transfer their energy to the thermal energy store of the surroundings, okay? That will all eventually be transferred to the air, basically. This is done by one of the 4 energy transfers and can be shown using an energy transfer diagram. Okay, so this example, it's a hot metal again. So basically the thermal energy is in the thermal energy store of the metal. This will be transferred to the thermal energy store of the air surrounding it, okay, and also be transferred into light waves. Okay, so 2 different types. So some examples that you can do, okay, you can do these right now. Okay, so if you clap your hands, okay, the kinetic energy store of your hands, okay, because you're moving your hands, that's kinetic energy, okay, will be transferred to thermal energy, okay, to the surroundings, because you can't really notice it because it's only very, very small, but if you kept clapping for a long time, your hands would heat up and you would notice it, okay. The other thermal energy store, energy store, sorry, is the sound, okay, because you can hear your hands clapping. Okay, the other one that you can try is if you rub your hands together, okay, you can feel the thermal energy building up, okay. So as you're moving the kinetic energy, you're transferring the kinetic energy from your hands moving to the thermal energy store of the surroundings, okay. You can feel it on your hands, but it's transferring to the environment, okay. Right, I hope you've enjoyed this short video. Thank you.